In our last video, we spoke about solving for x, and we determined that unless and until the x is all by its lonesome, we have not solved for x. And we spoke about drawing a circle around the side of the equation that contained the variable, and then if there was anything inside the circle other than the variable, in this case x, that meant we have not solved the equation for x and that we had more work to do. So clearly, this equation is not solved because we have a neighbor associated with the variable. So let's talk about how to get rid of that neighbor, get rid of that mangler, and in the process, isolate x and therefore by definition, solve the equation. In addition to noticing that this equation has a neighbor, I want you to focus on the operation that's being performed between the variable, namely x, and the neighbor. And that operation is addition. What we are going to do is we are going to use the opposite operation, in this case, subtraction. And we are going to use that to our advantage to get rid of that neighbor and to isolate x. Let me show you how to do that. The first thing we do is we rewrite the beginning of the equation. And then, as promised, we come along and we use the opposite operation and we keep the neighbor the same. For now, I am going to ignore the right side of the equation and focus only on the left side. When we place a -2 immediately after the +2, this simplifies to 0. Therefore, we have x plus 0, which simplifies to x. We have therefore accomplished our goal. We have gotten rid of the original neighbor, and we have isolated x. And I wanted you to notice the fact that we have isolated x by adding the -2 and having these two numbers combined to 0. This is not an accident. That was done by design. Having these two numbers simplify to 0 was our plan right from the get-go. Now, we are not done yet. We are not done because, as I mentioned, we have not discussed the right side of the equation. So let's go ahead and rewrite the equation, like so. And I want you to notice that this equation has an equal sign. In fact, that's the definition of an equation. An equation not only has an equal sign, but it has a left side and a right side. Or some people will call this side A and this side, side B. When you place an equal sign, it is a serious situation. In my opinion, the equal sign is the most important symbol in mathematics. The equal sign is of stratospheric importance, monumental importance, operatic importance. And the equal sign should not be placed casually or willy-nilly or haphazardly. Because when you place an equal sign, what you are telling me is that you have a level seesaw situation. Okay? And like an equation, a seesaw is going to have a left side and a right side. And let's say on the left side we have some items here. And on the right side we have some items. They may look a little different, but in the end analysis, because the seesaw is level, by definition, the left and the right side of this seesaw have the same weight. Just like the equation above it, the equal sign tells us that the left side and the right side of this equation are equal in value. So if you come along and you adjust the left side of this equation, like we did on the left side of your screen during the process of isolating x, this equal sign no longer applies. It's no longer valid unless and until you do the same exact thing to the opposite side. Not a similar thing, the same exact thing to the opposite side. If you think about it, when we put this minus 2 here, during the process of isolating x, effectively what we did, if you look at the seesaw analogy, is we came down here and we took away some weight. Once we did that to the left side of that seesaw, we no longer have a balanced seesaw, and you have this type of phenomenon. The seesaw will not stay balanced unless you come along to the right side and you take away some of its weight. Now, not some of its weight, the exact same amount of weight that you took off on the opposite side. Excuse me. Okay, let's go back to our equation. Let's erase our seesaw. Okay. Let's review what we did. Our original equation was x plus 2 minus 17. In an attempt to isolate x, we took away 2 from this side. That manifested in these canceling out. We had x plus 0, which simplified to x. We must do the same exact thing to the opposite side to keep the integrity of that equal sign intact. Once we do that, this will simplify to 15, and this is your final answer. Now, ladies and gentlemen, I cannot emphasize enough the importance of the equal sign and the maintenance of the integrity of the equal sign. If you come along and you alter one side of the equation like we did, you cannot argue with a straight face that that equal sign is still valid unless and until you do the same exact thing to the opposite side. In our next video, we're going to talk about solving for x when there are different operations being done between the neighbor and x, namely multiplication and division.